Assalamu alaikum. My name is Al Hasib. My ID is 221155074. I am from section I. So today is our numerical method presentation. My topic is bisection method. So here we start. First of all, our contents, definition of bisection method and basic information of bisection method. Then we also see algorithm of bisection method. Third, calculated of root by using bisection method with the help of important example. And last one, advantage and disadvantages of this method. So here we start from definition. So, the bisection method in mathematics is a root finding method which repeatedly bisects an interval and then selects a sub interval in which a root must lie for further processing. That's our definition for bisection method. So here we can see the algorithm of bisection method. First of all, we have to choose two real numbers, a and b, anything you can use, such that function of a and function of b, where function of a into function of b less than 0. Then define root c equals to a plus b divided by 2, and also calculate function of c. If function of a into function of c less than 0, then set b equals to c. If function of v into function of c less than 0, then set a equals to c. To step 1 until find the root matched twice. Why? Let's we see. Here we have a function. Find out, here we have a question that find out the root from the following function using bisection method, where is the function is a function of x equals to 3x minus cos x minus 1. So we have to solve this. We have to take our root from this function by bisection method. How? Here we have to create 6 row. First of all, we have to create a for a from a value of a for value a, for b value, and one for function of a value, one for function of v value, one is for c value, and one is for function of c value. Here, first of all, we have to take two value from one is 0 and one is 1. Then we have to put these two number in the given function in our question, and in our question, and we have to see for first we have to see for 0, and first we have to see for 1. Then we have to see if here we can see we take a equals to 0 and b equals to 1. Here for a equals to 0, when we put this 0 in f function of x, then we can get minus 2. And when we put 1 for b equals to 1 in the function of x, then we can see f1 equals to 1.46. Here, which two number we should take? We can use more any other number. Like if we want, we can if we have to see first that our f a and b value, when we go for the calculation, and we have to see is this our number is less than 0. Here we can see one we got minus 2 and one we got 1.46. If we calculate these two number, we can get a minus value which is less than 0. If this not happen, if the calculation of these two number is plus, which is not less than 0, which is greater than 0, then our function these two number is not being for this. So then we have to increase the number, like for we should left 0 1, then we should take for a 1 and take for 2 for b. If we then we have to increase for this bisection method we not have to increase too much. This is a good point. So here our there is we got our less than 0 number in 0 and 1. This is good. So here we can take 0 and 1 for a and b as a value. So for function of a and function of b we have to get this number. This is easy because we take a equals to 0 and b equals to 1. These two number after the take these two number in function we get -2 and 1.46, which number we take here in the uh, in this table, and then we have to get c. How? C equals to a plus b by 2, what we can see in the algorithm. So which a and b number we have to plus these two number and then divided by 2, and then we get 0.5. And this c number, when we got the value of c, this value we should take into the function. This 0.5, this 0.5 we have to take here in this function 3x minus cos x minus 1. After we use this number here, we get minus 0.38, which is function of c number. Okay, then we can we have to follow this algorithm. We have to see if a into fc, if this number is less than 0, then b equals to c. If fb into f function of c less than 0, then we have to take a equals to c here. So first we have to see f a into fc. If we calculate these two number, we have got a plus number which is not less than 0. That's why we can't use b equals to c. So if we see fb into fc, then we can see we can get a minus number, and this is less than 0. That's mean we can use a equals to c for that by the algorithm. So now for the second line we have to take a equals to c. That's mean this c number 0.5 we should come, that should come in the place of a. Then a's value is 0.5 and b's value is not been changed. That's been same like the first. If here our function of a into function of c in is been less than 0, then that's mean we have to use b equals to c. Then this number should come here in the b, and the rest of the a number is been the same 0. But now we can see fb into fc equal less than 0. That's why our a equals to c is come here in this table. Then we have to same process we have to go. We take these two value in the function, then we can get fa, a function of a and function of b. Then we can get c's value from ab, and then we use this number in the function, we can get 0.52. In the same process, same way we have to use a same way we have to go more further. How much when we can see our c value 0. Here we can see our c value comes 0.61, and then we try again, but this time c equals to also not coming same 0.6. But then after done another line we can get 0.61 again. When we see our c's value is come same twice by the algorithm to step 1 until find the root match twice. Here we can see our root value, which is c, is been same twice 0.61. That's mean this number is our root. This number is our root for the function f x equal to 3x minus cos x minus 1. So that's how we have to go by this algorithm, this process, the bisection method process. We have to follow this until we get the same root value twice. So this is the bisection method for us. Uh, and that's the way how we can use this bisection method to get a root. So for this method, the 0.61 is the root. So we also have to see the advantages and disadvantages for this method here. uh, Sorry, the advantages and disadvantages of this method is the advantages for this: simple and easy to implement, which is good. uh, Always finds a root, that's also good. We in By this method we must get the root. If you can't, then your method, the process is not right, not correct. And another advantage is no knowledge of the derivative is needed, that's good also. And the disadvantages: slow to convergence, this is very much slow, this takes some time. The good thing of numerical method courses is we can get with this, the process is very easy, but that's take too much time, which is some disadvantages for us. And also some equation roots cannot be found, some equation roots cannot be found, which is acceptable. Sometimes it's happen. And not applicable when here are multiple roots, not applicable when here are the multiple roots. We have to choose they are to same time twice, not different. So that's our presentation for the bisection method. I hope you enjoy. So this is from me, Al Hasib, about my presentation for this numerical method course. So I hope you like that. So thank you very much for giving me the opportunity to uh, talk about this method and also for my presentation. So thank you so much, sir.